Welcome to this video on work and power, where we calculate the work done and the power generated in pulling a sled at an angle to the horizontal. You are pulling your younger sibling of mass 32 kilograms on a 12 kilogram sled as shown. You pull the sled at an angle of 32 degrees above the horizontal. If you drag them 95 meters in 4 minutes and the force you apply on the rope is 120 newtons, in part A we'll calculate how much work you have done. In part B, we'll calculate what power in watts you have generated, and in part C, we'll calculate what power in horsepower you have generated. To solve part A, how much work we've done, we use our equation for work. Work is equal to force multiplied by displacement. We know that work is only done when the force and the displacement are in the same orientation. And in our diagram, the force is at an angle of 32 degrees to the horizontal, and the displacement is horizontal. So we need to break up our force into its components of horizontal and vertical. So let's make this triangle a little bigger right down here. Because the sled is being displaced horizontally and work is only done when the force and the displacement are in the same orientation, to calculate the work done, we're going to have to multiply the horizontal component of the force, Fx, by the displacement of the sled. We find the horizontal component of the force f of x using trigonometry. So Fx is the adjacent side. So cosine of the angle is equal to the adjacent side divided by the hypotenuse. Substituting our values, we get cosine of 32 degrees is equal to f of x over 120. Solving for our variable fx, we multiply both sides by 120. So on this side, 120 divided by 120 is 1, and we're left with f of x, the horizontal force, is equal to 120 multiplied by cosine of 32 degrees. Plugging the horizontal component of the force Fx and our displacement into our equation for work, we get work is equal to 120 cosine of 32 degrees multiplied by the displacement, which is 95 meters. 120 newtons, I just forgot the units here, multiplied by cosine of 32 multiplied by 95 meters gives us a work equal to 9,667.75 joules, keeping a few extra decimal points. So our final answer for the work is equal to 9.67 times 10 to the 3 joules, or 9.67 kilojoules. Again, we have to decide if this is positive or negative work. So if we look at our force and our displacement, our force was in the right-hand direction and our displacement was also in the right-hand direction. So because our force and our displacement were in the same orientation, this is positive work. You may have noticed that the mass of the sibling and the mass of the sled never came into play in this question. And let's for a moment consider the forces that these masses contribute. So these masses contribute forces in the vertical direction. So the force of gravity downwards due to the mass, and opposite the force of gravity, we have the normal force. So it should make sense that we never actually needed the mass, because remember, work is equal to the force that's in the same orientation as the displacement. And both the force of gravity and the force normal are perpendicular to the displacement in this case, so they don't come into play. We're now ready to calculate part B of this question. So let's just add our unrounded value of work to the side here. So we have it for part B. Work is equal to 9,667.75 joules. In part B, we're asked to find the power in watts that was generated as the sled was dragged 95 meters in 4 minutes. So we use our equation for power. Power is equal to the work divided by the time. Before we can use our time to calculate our power, we're going to have to convert it from minutes to seconds. So to convert 4.00 minutes, we have to multiply the 4 minutes by a conversion factor that has minutes on the bottom, so our minutes on top and on the bottom cancel, and seconds on top. There's 60 seconds in 1 minute, so our minutes on the top cancel with our minutes on the bottom, and 4 multiplied by 60 is equal to 240 seconds. And now we're ready to substitute our values into our equation for power. So power is equal to the work, and the work is equal to 9,667.75 joules. We keep the unrounded value to avoid rounding errors, and we divide this by the time, which is 240 seconds. 9,667.75 divided by 240 seconds gives us a power equal to 40.282 watts. And this rounds to a value of 40.3 watts. So what power in watts was generated as we dragged the sled 95 meters? We generated 40.3 watts. Let's add the unrounded value to the side here for our power so we can use it in part C, 40.282 watts. In part C of this question, we're asked to calculate the power in horsepower that was generated as we dragged the sled 95 meters. And again, for this, we just do a unit conversion. 1 horsepower is equal to 746 watts. And we found in part B of our question that we had a power in watts of 40.282. So 40.282 watts. We multiply this by our conversion factor, and we need watts on the bottom because we want it to cancel out with the watts on the top, and horsepower on top. We know there's 746 watts in 1 horsepower. Our watts on the top canceled with our watts on the bottom, leaving us with our desired unit of horsepower, and 40.282 divided by 746 gives us a final horsepower of 5.40 times 10 to the negative 2 horsepower. So what power in horsepower is generated by dragging a sled 95 meters in 4 minutes? 5.4 times 10 to the negative 2 horsepower. Thank you for watching this video on work and power, where we calculated the work and power generated by dragging a sled at an angle.